Bismillahirrahmanirrahim. Assalamu alaikum. Time to start chapter 2 of D2, and this chapter is regarding linear graphs and simultaneous equations. To start linear graphs, let's take the general equation of any line, so which is y is equal to mx plus c. So it is a general equation for any line where this m is gradient, this c is y-intercept. So now the question is, what is the gradient? So gradient is basically the measure of steepness or a slope. It tells us that whether the line has a positive slope or a negative slope. So what do I mean exactly? Let's take this general graph. Suppose I have a graph like this, and this is origin. So we are going to study this graph from left to right. Okay. So if we study from left to right, we can see that it's a moving upward line, right? So if it's moving from this point to this point, it's moving upward. So this is going to have a positive slope. That is, this gradient of this line is positive, right? Now, if we have a graph like this, this is origin, we are moving from left to right, and we can say this is moving downward line. So it's going to have a negative slope. Okay. So gradient is basically to measure, or it gives us the steepness or a slope of the line. It can be positive, it can be negative, but now how to calculate the gradient? And for that, let's take another graph and we'll calculate the gradient from that graph. Okay. Okay, we have a this graph, and this our y-axis, this is our x-axis. Okay, this is origin, moving left to right. We can see that line is moving upward. So we have, what we can see by looking at it, we can see that it's going to have a positive slope. The gradient is going to be positive. But how to calculate the gradient? Okay, for the gradient thing, how to calculate? So for this, you have to point out what are the coordinates at this point, starting point. The coordinates are, x coordinates are 0 and y coordinates are 1. Now if we reach at this point, just if we see like this, so the coordinates at this point are 3 and 4. Okay. Now to calculate the gradient, what we have to do, from this point the line has moved upward to this point. So we have to see what is the vertical change, what that vertical change has occurred. So first thing is, what is the vertical change? And then we're going to see what is the horizontal change. From moving from left to right, it started from this point. What is the horizontal change? Okay, so vertical change divided by the horizontal change. So what is basically vertical change? It is showing how much the line or the graph is rising. So it is also known as rise over, from moving from left to right. What is the movement from 0 to onwards? So it's rise over run. Or to make it further easier, in the terms of coordinates, what are we going to say? Initially the coordinates were x1, y1, and the endpoint, towards the endpoint, the coordinates are x2, y2. So for the vertical change, what are we going to do? We're going to subtract initial coordinates from the ending coordinates. So it will be like this for the rise. So the rise is along y-axis. So we're going to take y coordinates. y2 minus y1. So we are going to take the ending coordinates first and the starting and then subtracting the starting coordinates. Okay, and for the run we are going to take x coordinates, so which is x2 minus x1. And in this case, what is happening? What is y2? 4 minus what was initially position of the y? It was 1. Okay. What is the x position? 3. What was the x position initially? 0. So it is 3 over 3, which is equal to 1. So it's a positive slope, right? This is what we guessed while looking at it, that it's going to have a positive slope. And now we have applied this formula, and through this formula we have known that vertical change divided by the horizontal change is going to be 1. It's a positive thing. And also how to use the coordinates. What we are going to do, we are going to subtract the endpoint coordinates from the initial, and then we are going to take initial coordinates, and subtracting both we will get this. Okay. Now coming to the y-intercept. What is the y-intercept? We have gradient now. The y-intercept is the point where the line is intercepting the y-axis. So this line is intercepting the y-axis at this point, which is 1. So the y-intercept in this case is 1. And if we apply to this, what's going to be the equation? Y is equal to x plus 1. Since we don't write 1 here, so the equation is reduced to x plus 1, right? So now let's take another example to see how the negative slope is calculated. I mean, the formula is going to remain the same. It's just the position of the graph which is going to make the gradient negative. So let's take that example. So we have another graph here. This is our y-axis, x-axis, okay. So for sake of simplicity, what are the coordinates over here and what are the coordinates over here? Let's see. The coordinates here are 0 and 6, and what are the coordinates here? They are 4 and 0, right? Here x coordinate is 0, here y coordinate is 0, because both the points are on the axis line. Now we have to calculate the slope, and looking at this this graph, moving left to right, we can see that it is downward graph. From here it is coming down, so it's going to have a negative slope. So let's see. y2, what is y2? Starting from left to right. Now this is not y2, we have to move left to right. So what is y2? It's 0. Minus, what is y1? 6. We are moving left to right. Remember, don't take it as a x2, y2. This is basically x1, y1. Okay? This is x2, y2. So minus 6 divided by x2, which is 4, minus x1, which is 0. So we have here minus 6 over 4, or minus 3 over 2, or it is minus 1.5. Okay, so we have our negative slope. The gradient here is minus 1.5, and the y-intercept C is the point it is intercepting the y-axis is 6. So we can say that this equation is reduced to 1.5x plus 6. Okay. So this is how the gradient is calculated. We have to look at the graph left to right. Keep in mind what are our initial coordinates and what are going to be the second coordinates or the end coordinates, and then we are going to subtract the initial coordinates from the second or end coordinates, and then we are going to get our gradient, and we are going to look at the y-axis where the line is intercepting, and we'll get our y-intercept. Okay, you got, I think by now you got the basic idea of the gradient and the y-intercept. We'll do another example next time, and we'll move towards how to use the graph for solving the simultaneous equation. Thank you very much.